Okay, we're talking about solving exponential equations today. This is section 8.2. All right. One thing that would be nice if you still have the little chart that had the powers of 2, like 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. Yeah, if you've got that green cardstock, it might be helpful for you. If you really got exponents really well and you kind of memorized the 2 to the 2 to the second. Everybody should know all the powers of 2, right? But 2 to the third was 8, 2 to the fourth is 16, 2 to the fifth is 32. You need to know those to do the problems that we're going to look at today. So you want to know as many of the powers as possible. Otherwise, you're going to have to mess around a little more than you might like on your calculator. The point is, we're going to want to change the bases to get them to match so that we can solve these problems. So what I mean by a base is the number that you're taking to a power. If you're solving an exponential equation, all the properties of rational exponents that you know also apply to real exponents. Rational exponents, remember, were fractions. Okay. Remember that a to the m times a to the n equals a to the m plus n. You add the exponents when you're multiplying like bases. And when you have a base to a power raised to another power on the outside, you multiply. And when you divide, you subtract. Okay? And also you want to remember that a to the negative n is 1 over a to the n. Remember that negative exponent rule means the reciprocal. So if you got along fine with these exponent rules, this won't be that bad for you. If this was something that was difficult, then it's not going to be as obvious. Hopefully we do understand those rules. So the property of equality for exponential functions says, if b is a positive number other than 1, okay, meaning greater than 1, then b, or it could be a fraction, b to the x equals b to the y, the base raised to the x power equals the base raised to the y power, only if x and y are the same number, same amount, okay, that they have to be equal. So if I want to solve this equation, what they did here is they rewrote the 4 in base 2. You can rewrite 4 as 2 to the second. It's equivalent to 4. And so what they wanted is to have this base of 2 match the base on the left, and so they changed 4 to 2 to the second. And then that power out there, x minus 1, that was the exponent on the original problem. It's still there. What happens once you get the bases to match, you can drop the bases and set the exponents equal to one another and solve it. So what they do next would be is multiply through 2x minus 2 equals x plus 5. And then you would solve this by subtracting x from both sides. And I don't normally write that step, but x minus 2 is 5. And then you would add 2 and you would get x is 7. Okay. All right, now we are going to try and practice some problems to try to get this idea across. So solve each equation by showing all work. Once you see the bases already matched, you are ready to drop the exponents, drop the bases and set the exponents equal to one another. Since both of the bases are 3, you can set the exponents equal to solve for x. We would subtract x from both sides, and then we would add 1 to both sides and get x is 3 for that problem. You can plug back in if you like to see if you're getting the same answers on both sides. And this would give you that 6 minus 1 is 5. 3 to the 5th would be on the left. If you put 3 in here, you'd get 3 to the 5th on the right. So it checks out. The next one, number 2, the bases are different. We would rewrite the 4 as a base of 2. 2 to the second is equivalent to 4. And I think this might be the one that was already shown. Is it? Okay. So we drop and distribute if needed. And then we found out that was x was 7. That was the example. Can I change pages? All right. Number 3, what base do we want to get into? 2. All right, so since you have 2 on the left as a base, you're going to look at the smaller amount. Change the 4 to 2 to the second. So we're going to trade 2 to the second for 4. And then we'll have x plus 2. Don't forget that parenthesis around the exponent. So now we'll drop the bases, and we'll have 3x is equal to 2 times x plus 2. You can just distribute right away if you prefer. 3x equals 2x plus 4. Once you distributed, and you would subtract 2x and get x is 4. Then we get to number 4. Base on the left is a 3. So since this is already in base 3, I can't change a 3 into anything else, all right? I mean, I could, but I'm going to look over here now and say, can I change the 1/9 into the base of 3? Well, some people might not recognize that right away, but you do know that 9 is equivalent to 3 squared, right? So how could you make it be the reciprocal? 3 to the negative 1, that would be 1/3. So what do you actually really want? I want 1/9. How can I get a reciprocal of 9, which is what 1/9 is? I've heard somebody say it. I think I've heard the correct answer, but I'm trying to get everybody to think a little longer. What could I do to the power of 2? Yeah, we're going to make it negative because 3 to the negative 2 is 1/3 squared, which is 1/9. That's why I'm telling you understanding the exponents was really important. So I'm going to trade 1/9 for 3 to the negative 2. Okay, I think, how many of you saw that before? I kind of was eking it out there I wanted to give more people a chance to think. Okay. All right, so now once the bases matched, we drop the bases and set the exponents equal. We would need to add 1 to both sides. That would give us -1. Divide by 2, and we get -1/2. Okay. Number 5. Now we have a base of 4 and a base of 8. Can I write 8 in a base of 4? Do you know a power of 4 that gives you 8? No. So instead, we're going to not work with, we can't always use either one of these. Sometimes you have to change both of them. We have to change both in this case. So what is a base that we could change to that would give us a 4 and an 8? Base 2. All right. Because we know 2 squared is 4, and we know 2 to the 3rd is 8. That's why I was saying it'd be nice if we had those memorized. Okay. So I'm going to trade 4 for 2 squared to the x plus 1. And that's going to equal 2 to the 3rd to the 2x plus 3. We're going to have to drop the bases now and do 2 times x plus 1. If you want to distribute right away, you certainly can. 3 times 2x plus 3. Distributing, we get 2x plus 2 equals 6x plus 9. And then we subtract 2x from both sides. And then if we subtract 9, we get -7. And then if we divide by 4, we get -7/4 for our value of x. Now I'm going to tell you, this is about the only way I'm thinking anybody would have figured that out. You need this method because it's slick and it gets you an answer that's not very nice. I sure wouldn't want to guess and check what x was. That'd be no fun. Okay, number 6, a little bit trickier to think about, but I think the 36 is your hint. We can't do bases of 36, but what base could you change a 36 to? Base 6. Okay, so 6 squared is 36. And then that chart actually has 216 on it. I don't know if I went up to 6 though on the chart, did I? I might have. Yeah, we did. What power of 6 is 216? Oops. It's 6 to the third, isn't it? Okay, so that's why we're trading 216 with a 6 to the third. And then we'll go ahead and do the distribution. We'll drop the bases, and then I will distribute. Okay, so we got 4x plus 8 is equal to 3x plus 15. Subtract 3x, and then subtract 8. You should be getting 7. Yes? Okay, I got 7. All right, great. What base? I think the number 7 is a little obvious about what base we're going to have to use. 5. Yeah, you can't change the left. 5 to the 2x minus 1. Now, I need the reciprocal, but I got to think, what power of 5 gives you 125 to the third? So then we'll just make it 5 to the negative 3 because we need the reciprocal. All right, then we can drop them. 2x minus 1 equals negative 3. 2x equals negative 2, adding 1, and then we get negative 1 for x. All right, anybody still need this page? All right, number 8. Okay, we got to change both sides. 27 came up a lot of times. What power of something was 27? Okay, 3 to the third is 27. Okay, 3 to the, let's see, if you did 3 to the fourth, that's 81, and then 3 to the fifth is 243. That's the stuff I'm thinking about when I'm trying to decide what to do. So then I'm going to go, well, 1/27th is the reciprocal of 3 to the third, so we're going to do 3 to the negative 3. Replace the 3 to the negative 3 for 1/27th. And then 1 over 243, we're going to trade for 3 to the negative 5. Okay, dropping my bases and distributing, I get negative 6x minus 3 equals negative 15x plus 10. Any problem with the fact that I did that all at once? Did I lose anybody there? I just didn't write this down equal to that right away. I went ahead and distributed right away. Okay, I would add 15x to both sides, which would give me 9x minus 3 equals 10. Yeah. Okay, then I add 3, get 13. Then I divide by 9. Is this correct? Did I do anything? Yeah, I've got 13/9. I just don't remember it, so. All right, great. The next one, number 9, base is going to be 2. 1/2 is 2 to the negative 1. 8 is 2 to the third. So then distribute. And add x to both sides and divide by 7. Not 3. It's 3/7. How many of you are ahead of me now? Thought maybe a couple of you. Not okay, not too many. All right. I will keep. I might be going too fast. Am I going too fast for anyone? Sure. Especially, yeah, if you make a boo-boo and you're ahead. Does anybody need me to explain anything else on here? Any more? Okay. Make sure we got phones put away. All right. Are we good? Number 10. Oh my, 32 and 128. Well, 2 All right, this is 2 to the 5th is 32. Okay, so I'll take that. And wait a minute, though. What about the 128? Well, now let me show you how you can figure it out. 2 to the 5th, you got 32. 2 to the 6th is twice that, 64. And 2 to the 7th would be twice 64, which is 128. Okay? So we're going to trade 128 for 2 to the 7th. All right, I'm going to distribute. I got 15x minus 20 equals 28x plus 12. No, excuse me, I messed up. 28x plus 21. All right, subtract 15x from both sides. I get 13x plus 21. Subtract 21, I get negative. I don't know how I got 12. This should be minus 20. No, I saw it right when you started to say something. I'm like, why did I write 12? This is a negative 20. And then when I subtract 20, I had negative 41. And then I get negative 41 over 13. Now, I'm serious. I would never be getting that answer if I didn't have this algebra. Who's going to guess that? Not me. All right, now we're going to do some investment. This is much like yesterday's. Y equals A, the initial amount, times B to the X. B was the growth factor. Okay, and then remember we had the ones that went Y equals A times 1 plus R, right, to the X or something, P. Okay, these are relatable to that. But this time, this is about investments. And you have a little line, you have something there that talks about this, and I don't know where that page is in my little, this isn't a PowerPoint, it's a smart notebook. But you have something that's explaining the values, right? A line. P stands for principal, which is your initial amount. That's like your A, okay? It's your initial investment. Beginning amount, amount in the account, whatever you want to say. 1 again is the 100%. And then R is, of course, the rate, and N's the new thing, is the number of times it's compounded per year. Number of times compounded. I think you have this all written down, though. Now, you're going to need to know that you can compound your interest annually, biannually, quarterly, monthly, daily, and instantaneously. We're going to round our answers to the nearest hundredth, and we're going to do $1,000. That's the P. This is the first problem, correct? Yeah. 4.5%, your rate is a decimal, would be 0.045. Compounded annually would mean N is once a year. And of course, T is the 5 time. All right, so we're going to write an equation. I'm just going to fill in A of T. What that means is the amount in your account over time is given by the following equation. 1,000 times 1 plus 0.045 divided by N, which is 1, to the N1 times 5T. 5 is the T value. So then you go and you could actually simplify this to 1,000 times 1.045 to the 5th and just type that on your calculator. Do we need me to type it in? Otherwise, I can just jot down the answer you should have gotten. And that is $1,246.18, right? Anybody have a problem getting that value? Yes, you did, Scott? Okay. Okay, then something is wrong with how you typed it. So it should be 1,000. Just try typing it again. Parenthesis 1, and then you could put 1.045. If you did plus 0.045, did you have 0.045? Okay. Close it to the 1 times 5. If it didn't stay in an exponent, then it would have gotten a lot bigger. So I'm not sure what happened. You get it now? Did you try again? You really need to practice typing these to make sure that you're getting them and not just waiting for someone else to give the answer. Which I wasn't talking to you, Scott, because obviously you did it. Okay, how about it? Are you okay now? Yeah. At least let's try another one. Okay, so this P is your 800. Your 0.062 is your R. Compounded monthly makes your N be a 12, and your T is 10. So the amount in your account over time would be $800 times 1 plus 0.062 divided by 12 to the 12 times 10. All right, that one, you cannot add the 1 plus the 800 divided by 12 unless you type that on a calculator. So we're just going to go 800, parenthesis, 1 plus 0.062 divided by 12. Close your parentheses and then arrow up. And if I were you, I would probably multiply that out. Most OS systems, it's easier to just say 10 times 12 and do 120. You can type it in, though, as 10 times 12. Just make sure that your exponent, it stays an exponent the whole time. And our answer should be $1,484.77. Okay. Number 13, P. What's the matter? Did your exponents stay together? 12 times 10? You found it? Okay, so P is 2300.08 is your rate. Compounded daily, that's going to be an N of 365. How many days are in a year? 365 and a quarter, actually, but we do a leap year day for that quarter. It actually takes 365 and a quarter days to go all the way around the sun. Okay, 7 years, of course, is your T. All right, so our amount in our account over time is 2,300 times 1 plus 0.08 divided by 365 to the 365 times 7. I forgot the rate already, 0.08 divided by 365 to the 365 times 7. Okay. Should be $4,026.30. All right, go for the next one. The most common mistake is the compounding numbers and then also changing your percentage increase or decrease to a decimal. And of course, these are all increases because we're investing money. Okay, did you guys get that? Oh, I think I put in, did I put in too many zeros? Oh, this is not an exponent. That's what's wrong with that. Okay, so I can fix it by hitting second enter and backspacing, arrow up, 12 times 3, close it, arrow over there to that 2 and delete it. That better? 12,589.20. Oops. It's going to be 30, isn't it? 12,589.30. Okay. I don't know. I forgot. What was it? Is that right? 539? Thanks. Didn't remember very well. Okay, the Garcias have $12,000 in a savings account, and the bank pays 3.5% interest compounded monthly. Find the balance in 5 years. All right, you got one more to calculate, and then we're going to do something. Oh no, we got actually the different one's going to be 17. Okay, Garcias over time. We're compounded monthly on this one again, so that'd be an n of 12, and we're going to do 12 times 5 for the exponent. Okay, calculate and then check your answer, please. All right, and then check what happens on number 16. I'm going to pause for a moment while you guys do that. So these are the answers we got or should have gotten after doing the 3 different problems for 16. What's happening as you increase the number of times it's compounded per year? The value in the account goes up. Okay, so what would be the best compounding you could get? Daily, based on what we've talked about today, but what if they told you they'd do it twice a day? What if they said they'd do it every minute? Okay, now there is going to be something we're approaching, which is instantaneous compounding, and we're going to learn about that this week too. So there's a special one for that, and I'm going to teach you what that number is that gives you an instant compounding. But for our purposes right now, the more often it's compounded, the more money you're going to make. Why is that? So I know you're thinking correctly, but let me say it a little bit differently than what you said. Each time you're compounding, if you're compounding it more often, you're compounding interest upon interest. So if it only happens once a year, you're only getting interest one time. If you're compounding it more often than once a year, you're getting some interest, and then you are taking interest on that interest. So it's increasing exponentially. Okay, it's going up more and faster and faster. Okay, so that's why you want to get it compounded as often as possible. So if you go to a bank and they just say to compound your interest annually, that's not very good. You don't want that. If you invest $50,000 in a high interest account that earns interest at an effective rate of 3.8% per year, compounded daily, how many years will it take to double? All right, well, we know how to write the equation for the amount in the account over time, which would be 50,000 times 1 plus 0.038. Compounded daily would be 365. But we don't know how long to the tape. But what do you want in your account if it's going to double? Okay, double the 50,000 would, yes, be 100,000. Okay, where would that go into your equation? The amount you want in your account. Now, you could put that in there. But let me ask you this. Do you know how to solve for t? Yes. Okay, so that's our alternative. We don't know how to solve for t yet because we haven't learned logarithms, which solve for exponents. But there is something we could do. So what I'd like you guys to do is put this equation right here, put that in your y1, and put 100,000 in your y2. Find out where they intersect. Now, anybody else want to do what I'm about to do? I'm going to do something that reduces this down. Yes. Oh, I don't know why I didn't write the 365 there. Of course there is, Scott. Thank you. Absolutely. 100%. I blew that one. I didn't write the 365t, guys. You need 365t in your exponent. But here's what I was thinking. So I'm going to reduce this down by dividing both sides by 50,000, which will give me 2 equals, and then I won't have to worry about all that zoom fit stuff. I'm going to put in my graph for this and this, because 2 stands for doubling. Oh, come on, thing. Where'd it go? Where? Oh, I did that second hour. It's still in there. Okay. So I'm going to hit graph. Now, wait a minute. What I had was zoom 6, and then I realized I can't see the intersection. Not hitting yet. So I had to increase and change my window so that I went from 0, say, to 20 years or something. Maybe it's going to take 25 years. I don't know. And then I press graph. Not going up real fast. Okay, so I wanted my money to double. And this isn't going up real fast because it was only 3.8% interest. So I hit second, calculate the intersection, choice 5, enter, enter, and enter again. And we got 18.24 years. Were you able to get that? Okay, so that first number is the number of years. It's about 18 and a quarter years. All right, I printed out for you the book page. I cut and pasted it onto a worksheet for you and made a worksheet. So please do those. And we'll be looking for that and questions on it tomorrow.